want to give you a short overview what is EVN. We are located in Lower Austria. As I said it before, it is around Vienna, and we also have energy business in different other countries, but the whole business we have in Austria, and I am of the DSO, and there I'm the head of the metering department. The Austrian legislation says we have to be changed all 90% of all meters to be smart by end of next year, and we have our goal, and we will reach the goal, to replace more than 800,000 meters in Lower Austria from Netz Niederösterreich. Our rollout plan of the company is orientated to this, to fulfill this legal requirement. And after long-term testing with different PLC communications was our decision to G3-PLC technology, and here thanks to Enlit to develop such a good PLC communication. As other utilities in Europe, we get the approval to use the FCC band in the range from 150 to 500 kilohertz. There are some requirements to use this. We have the condition to notch the carrier of the non-directional beacons, radio beacon of the airports around our district. And this is Linz, Vienna, Bratislava, Budapest, because these non-directional beacons have frequency in this frequency range. And this means for Netz Niederösterreich we can only use 44 of the 72 subcarriers in this FCC band. But our experience with the FCC band is very good. We have few disturbances of the PLC communication. How is the status of the rollout? We have started with 1st of October last year, and after 14 months rollout, we have installed more than 50% our customers a smart meter. The daily readout rate is around 98.5 until 99%. And when we have problem with the communication, when we have too much noise maybe, in some cases we install filters by our customers. And when you see we have more than 400,000 meters installed, we need in the moment 42 pieces of filters. In general was our experience with the cleanup to see if all meters are communicated in a substation area, that we need less time than we have planned in the beginning of the project. On our web page you can see this on the left side. On a weekly basis, the customer can see how is the status of our rollout, when we have started, we have finished some municipalities, or when will we start, when it's great for next year. Only to show you an example of our cleanup experience, there was in one feeder there was no communication possible. We monitor this all with our GIS system. You see this on the blue point. There was 1 meter, or there was one customer. He had 2 devices which sent a lot of noise. After we installed the filter, you see it on the right side. Everything is green. The blue one, there was a fault on the meter. But we go on the field, we measure the noise, and then we go in the household sometimes to find the device which sends us the noise. The next step is now to use the power quality data which will be registered by the smart meter. On one side we register time, state and duration of supply voltage dips when the voltage is below 90% or 207 volts. Over voltage it's more than 247 volts. It's not plus 10%, it's less. So we have a space to see, get the voltage too high when to install too much PV in this low voltage grid, and also we measure or register all voltage interruptions below 5 volt. It is a requirement of the Austrian regulator. And also by all meters we register the 10 minutes voltage value of the supply of each phase, and in each substation the meter of the transformer register all the power quality data. Our system, we read the meter with our head-end system, but we don't bring the power quality data in our meter data management system. We have a separate database where we evaluate this data, and we use it especially in the GIS system to get in a very short way the first overview about the power quality in the grid. Here you see two samples on the left side where the voltage is dark blue. It's too less, it's below 220 volts. And we saw that the level of the voltage switch of the transformer has to be changed. And on the right side, only of the transformer switch we have changed the level, the voltage increase, and in the low voltage grid we have always a very good level of the voltage. A second example is on the top you see it's also a little bit dark blue, that we have problem with the voltage, and we have to optimize the switch state of the low voltage grid. After we have done this, everybody is good. We have a good voltage, and we see it in a very short time what we have to do, where it is good or it's not good, the voltage. There's one other example, different. We had a problem with the neutral conductor, and if you see it here, we see that the voltage was like flicker, and we go on field to the cabinet and to see what is happening before the customer will get any problems. And there was a bad contact between the wire and the clamp, and after repair it, you can see it on the right side, the voltage level was stable. After we have control each low voltage grid, we have to delete the data on the database for privacy reason. So we make a check once a year of each low voltage grid. What is our summary, or what we see our big effort for us? That the power quality data help us to evaluate the power quality in each low voltage grid section. We are observing the development of the power quality data in the low voltage grid towards impact of additional connected PV systems, heat pumps and electrical vehicles. On one side, if we have too much PV systems, maybe Sunday afternoon, low load in the grid, we get over voltage, and we see heat pumps and electrical vehicles will increase in the future, and we have to control it, how we can handle this. And it's always focused to one substation area, and it could be different from substation area to substation area. And all this information is the basis to manage future investments in our distribution grid. To focus is where we'll have problems to invest in the grid and make the investments. Thank you very much for your attention.